Welcome to our channel. If you're ready to dive into the world of hardware design and verification, you've come to the right place. We break down complex concepts in System Verilog and Verilog, making them easy to understand through hands-on tutorials and real-world examples. Whether you're just starting out or aiming to sharpen your skills, we're here to guide you every step of the way. Hit subscribe, and let's innovate together. Let me give you a quick introduction to System Verilog and the XNOR gate. System Verilog is an advanced hardware description and verification language. It builds upon Verilog, adding features for design, verification, and modeling, making it more powerful for complex hardware development. With System Verilog, we can write more efficient and flexible code, especially for verification, using advanced data types, assertions, and object-oriented programming concepts. Now, about the XNOR gate. An XNOR gate is a logic gate that outputs 1 when both of its inputs are the same, whether 0 or 1. In other words, it gives a 1 when both inputs are equal and a 0 when they are different. It's the inverse of an XOR gate, and it's commonly used in digital circuits for equality checking and parity functions. Together, System Verilog and logic gates like XNOR are essential tools in digital design and verification, enabling us to build and verify complex electronic systems efficiently. Let me briefly explain the design of an XNOR gate in Verilog. This module takes two inputs, A and B, and produces one output, Y. The core operation here is an XNOR, meaning it outputs 1 when both inputs are the same, and 0 when they are different. The logic behind this is simple. We first perform an XOR on the inputs, which gives 1 when the inputs are different and 0 when they are the same, and then invert that result using the operator to make it an XNOR. A test bench used to verify the behavior of an XNOR gate in Verilog plays a crucial role in testing the functionality of the XNOR gate. Its job is simple. It simulates the gate by applying different input combinations and checking whether the output behaves as expected. First, it generates test signals by assigning values to the inputs, A and B. These inputs represent the two signals entering the XNOR gate. The test bench cycles through all possible combinations, 0, 0, 0, 1, 10, and 11. For each of these input combinations, it observes how the gate responds through its output, Y. Next, to help us visualize this, the test bench generates a waveform file. This file, saved as dump.vcd, records the input and output changes throughout the simulation. Using a waveform viewer like EPWave, we can see how the signals interact over time. Finally, after testing all possible input cases and ensuring that the XNOR gate behaves correctly, the simulation terminates gracefully. This completes the process of verifying whether our gate works as intended. In summary, the test bench automates the process of testing the XNOR gate, records the results, and ensures everything is functioning perfectly. To run your code on an EDA platform, here's what you need to do. First, write your Verilog or System Verilog code along with the test bench. Once that's done, compile the code using the platform to check for any errors. After successful compilation, run the simulation. This will execute the test bench and show how your design behaves. Finally, view the results in the console or, better yet, in the waveform viewer to see the signal changes over time. This lets you verify if your design is working as expected. And that's how you run your code on an EDA platform. The output of an XNOR gate is 1 when both inputs are the same, either both 0 or both 1. If the inputs are different, one is 0 and the other is 1, the output will be 0. Essentially, it checks for equality between the two inputs and outputs, 1 if they are equal and 0 if they are not. Thank you for watching. We appreciate your time and hope you found this video helpful. If you enjoyed it, please give it a thumbs up and consider subscribing for more content on hardware design and verification. We'd love to hear your thoughts and questions in the comments below. Till next time, keep learning and innovating.